One and all, this is Dwarkanath SK, Assistant Professor, Department of EEE, SJPIT, Bangalore. Welcome to today's video on powering equipment and appliances with the DC appliances. So the course is being Smart Grid and the target audience being final year electrical electronics engineering students, those who have opted professional elective of Smart Grids. So let us go into today's topic of discussion with respect to the powering equipments and appliances with the DC. So many energy consuming devices and appliances, they operate internally on the DC power in parts because DC can be precisely regulated for the sensitive components. So an increasing number of devices consumes DC. Examples: computers, lighting, ballast, television, set-top boxes, in motors for heating, ventilating, HVAC operations. So variable frequency drive machines, buses, all those things we will be seeing. So one by one we will be having a look into it. So numerous portable devices like cell phones, radios also require AC to DC adapter, and in some cases AC to DC combination of these, the wastage may go up to around 20% of the total power consumed. So equipment compatibility plays a major role. So EPRI comes into the role. So SMPS, including those for the computers, fluorescent lighting with the electronic ballasts, CFL bulbs, like baseboards and water heating units, UPS, and variable speed motor drives. So let's have a look into it one by one. So SMPS, switchmode power supply technology, they are used to convert AC of around 120 volts into the DC part, which is used internally for many electrical or electronic devices. So many opportunities exist to use DC power with SMPS, equipped with technology SMPS, which is found in many electronic devices for like desktop computers, laptops, with the power adapters of fluorescent lighting, ballast television sets, fax machines, photocopy, video equipment, and so on. So next, for the desktop and laptop units, according to research on the power supply efficiency with respect to U.S. Environmental Protection Agency, California Energy Commission, in the year 2004, there were nearly 2.5 billion electrical products containing the power supplies in usage in the U.S. About 400 to 500 million new power supplies sold every year. The total amount of electricity that allowed through these power supplies in the year 2000 was almost 207 billion kilowatt hours, about 6% of the national electricity bill. So researchers, they determined to go with the efficiency design to save expected nearly around 15 to 20% of that of the energy which is being usage. So moving on to the next one, fluorescent lighting with the electronic ballast. The key to DC operations of the fluorescent lights, they lies in the usage of the electronic ballast. Ballast is used to initiate the discharge and regulate the current low in the lamp. Modern electronic ballast functions in much similar to that of these SMPS, thus making it potentially possible to operate them from a DC supply. Virtually all new offices lighting systems use electronic ballast, which is more efficient and capable of powering the various lights at the lower cost. Next one is CFL lamps. They are energy efficient alternatives to the common incandescent bulbs. A new 20 watt CFL just use the same light output as that of 75 watt incandescent, and also offers an average life around 6 to 10 times longer than that of the incandescent. So CFL lamps, this has two parts: a small folded gas filled tube and a built-in electronic ballast. They are commercially lighting usage, which enables DC operation of the CFLs. And moving forward, for the electronic baseboards and water heating, DC loads, this can be used to run almost any devices utilizing electric heating element, including the resistive baseboards and the electric wire heaters. In these applications, you can find the electrical current lowering in a heating element which produces heat due to the resistance. The chief concern of using the DC in such application is not in the heating elements, but in the contraction switches and the circuit breakers, which is used for such circuits. So moving to UPS, they are the excellent candidate for the DC power support. It is consisting of an inverter with a high-speed static switches, various controls, and battery energy storage. Objective of the UPS is to provide high reliability and power quality for the connected load but may be susceptible to the voltage sags and the short duration power interruptions. Last application being the variable speed motors. Motors are very important electrical devices. They represent significant portion of the power usage in the US and not only in US globally. In industry, for instance, approximately around two-thirds of the electricity used is attributable to that of the motors. Most AC motor loads still use the same basic technology as the Tesla induction coil. These omnipresent motor which converts AC power for applications such as AC handling, air compression, refrigerators, air conditioning, ventilation fans, pumping, machine tools, etc. The work horsepower of the modern society, these motors can are only operated with AC power. In fact, it's if subjected to DC power, an AC motor can burn up quickly. So these are the various usages of the DC power application. So any queries, any doubts with respect to today's topic of discussion, you can write down to dwarkanath@cbat.edu.in and can subscribe to our department channel. So thanks for watching today's video and meet you in another interesting video which is the latest topic of discussion on the smart grid. Thank you one and all.